3D printing has been touted as the future of manufacturing, and now it could even be used to create replacement body parts. Kim Vanel went to the UK's biggest 3D print show to find out more.
Hello.
This is InMove, a robot controlled by voice command, built almost entirely using a 3D printer.
The hand has been downloaded 89,000 times already on the Thingiverse.
3D printing is the process of building an object from the ground up, adding material layer by layer. The technology is popular with architects, jewellers and product designers.
Rather than investing thousands of pounds in sending a prototype out and getting it back 7 days later, what they're doing instead is having the chance to bespoke create that on the desktop using one of our printers.
The possibilities using 3D printers are being explored in an increasing number of industries. The company behind this clay printer planned to print enough parts to build an entire house.
You don't have to be a 3D modeler or designer to create a 3D model. There's now scanning technology which can scan houses, it can scan cars, it can even scan people.
But plastic prototypes are just the beginning. This man, Faulkner-Jones, is printing with human embryonic stem cells.
Standard tissue culture and cell culture was two-dimensional. So basically you'd have the cells in standard medium and you just plate them out on a petri dish or a glass slide or whatever, and they would be fine in 2 dimensions. But in the body there are no 2-dimensional cells. They're in 3 dimensions. So you might get some cells at the surface which don't have any cells above them, but there are definitely cells below and to the side. So they need a 3-dimensional relationship. So the idea behind this machine was that instead of just printing with medium, we put the cells in a 2-part gel matrix so that then they could be suspended in 3 dimensions. And therefore, that's a more physiological environment. You get a better result. The cells actually do what they're meant to do. The things that we're concentrating on at the moment is the refinement of the cells themselves. So you can't just sling a load of adult cells in and expect them to do the job. So what you have to do is you have to use new young cells. So this is where your embryonic stem cells come in. But we don't want to use embryonic stem cells forever because they've got their own ethical problems. They've got the fact that you're still using cells from someone else, so you've still got organ replacement and tissue problems and rejection. So basically what we're working towards using induced pluripotent stem cells. So we're taking patient-specific cells, creating the structure, and then using that. So in the case of drug testing, it won't just give you an accurate human response, it will give you an accurate patient response. Animal testing is, of course, fundamentally using animals on animal cells, so that'll give you a very accurate response of what would happen if you did it to an animal. But if you were to do it on a human, most of the time the result is very different because we diverged genetically from animals a long time ago, so when you come to test it on a human, something completely different happens.
Could this replace animal testing tomorrow?
Not tomorrow, but in quite soon, I think 5 years.